What's up, everyone? This is James, and this is my lab 4 for Physics 2211. It's on energy. And so, in this lab, we took a look at a video with an oscillating mass on a spring, and then we're going to use this video to take the data from it using the tracker, and then compare it to a simulation that we're going to build using some code. And then using these two results, we're asked to demonstrate or determine the answer of two questions, which is the energy principle satisfied, and estimate the oscillation periods using the data from the tracker. Yeah, and so here are the formulas that I used. We got the energy formulas, which is kinetic energy is equal to 1/2 times mass times velocity squared. As you can see, my superscript doesn't work, but my subscript does work. As you can see, that's kind of odd, but whatever. And then potential energy of gravity, that's going to be m, which is mass times gravitational constant, 9.8 times where the ball is at, or where the mass is at compared to Earth, the surface of Earth. And then the spring potential energy, that's 1/2 times k, spring constant, times s squared. S is just the difference between where the spring's at the moment versus its equilibrium. Here are the force equations. We got force of gravity is equal to negative mg, and then force of spring is equal to negative k, spring constant, times s, which we already talked about, times L hat. And then we got the kinematic equations here. This is the velocity update formula, position update formula. You've probably seen these a bunch of times already, because this is lab 4. Yeah. And so here are the system of the lab. We got the Earth, the spring, and the mass. And yeah, let's go ahead and get into the code. Oh wait, no, before that, let's take a look at the video of the spring, and that's gonna be right here. Here we go. Oh, okay. All right, that was pretty cool. Oops, another one. Okay. All right, so let's get into my code. So basically, we use the initial position that we got from that. Solve for the initial ball position, ball velocity. Got the ball mass from this video right here, number 52 in week 9 lecture previews. And I also got more stuff from that. I got the where is it? Got the spring constant from that, and I got the spring equilibrium position from that. Basically, we're just using we're gonna use the initial data and create a simulation of the spring and its ideal, what it should look like, and then compare that to what it does look like my tracker data. And so I just plugged everything into the formulas here. As you can see, I already went over these. Also, energy is equal to kinetic energy plus gravitational energy of the spring and gravity. Yeah, I think I misspoke, but whatever. And just plug everything into the formula. So gravity is equal to that, spring force is equal to that, F net is equal to those two added together. Use that to find the velocity. Use that, put it into a velocity update formula to find the velocity, and then position. And then use that to update the spring after the position of the spring after that. All that happens, yada yada yada. Calculate all the energies, and then boom, it should look like this. Oops, gotta update. Put this in. And so this is my change in energy versus time graph. This is my x position versus time graph, and this is my y position versus time graph. Red is the experimental one that I got from tracker, and blue is the model. As you can see, they're running pretty close, which is really good. And then, as you can see, orange is completely on 0. That's good too. And then kinetic energy change of direction. All this looks good. All right, here we go. All right, all done. So yeah, all of it looks good. So to answer our questions, I would say the energy principle was satisfied pretty well. Total energy was kept at 0 throughout the entire simulation, which makes sense. As you can see, the experiment is kind of a little bit below what the energy or the position was modeled to be at, which kind of makes sense. There's probably errors air resistance, stuff like that. That'll affect it. And then the other question I'll answer with a spreadsheet. This is like an oscillation period. It's just going up and then down, like right here. And it's pretty much the same for the Y and X position. And so yeah, you can just use both Y and X position. Like oscillating, to find an oscillating period, you can use Y or X. It doesn't really matter. Yeah. All right, that's it. Thank you for watching my lab. Please give me 100. Thank you.